My name is Kengo Nakajima, University of Tokyo. Title of the presentation is H3-Open-BDEC, Innovative Software Platform for Scientific Computing in the Exascale Era by Integrations of Simulation plus Data plus Learning. First, I will make a brief overview the near future plan for Supercomputer Systems of Information Technology Center. Then I will talk about H3-Open-BDEC. In this study, we propose an innovative method of computational science towards the Exascale era and Society 5.0 by integration of Simulation plus Data plus Learning, S+D+L, where ideas of data science and machine learning are introduced to computational science. We are operating 3 supercomputer systems, and now introducing the BDEC system, Big Data and Extreme Computing, with more than 32 petaflops as the platform for integration of S+D+L. This slide overviews the 3 systems. We have more than 2,600 users, and more than 55% of them are from outside of the University of Tokyo. The oldest one is ReadBush by HPE, which consists of Intel Xeon Broadwell and NVIDIA Tesla P100, Pascal, GPU. This is our first GPU cluster. Oak Forest Pax by Fujitsu is our flagship system with 8208 Intel Xeon Phi many-core CPUs. This is operated by JCA-HPC, which is a joint work by University of Tsukuba and University of Tokyo. Total peak performance is 25 petaflops and it is 18th in the top 500 list, June 2020. The newest system is Oak Bridge CX by Fujitsu. It has 1,368 nodes of Intel Xeon Cascade Lake. Total peak performance is 6.61 petaflops, and it is ranked 60th in the world. 2 pie charts show research areas based on CPU hours on ReadBush. Left chart shows usage of ReadBush U, subsystem equipped with only CPUs. Computational science, such as simulations in engineering, earth and space science, and material science are the typical areas of usage of our supercomputer systems in recent 55 years. On the contrast, workloads on GPU cluster are very different. Large portions are occupied by information science related to artificial intelligence, and bioinformatics, such as genome analysis and medical image recognition by machine learning. Society 5.0 is proposed by Japanese government, aiming super smart and human-centered society by digital innovation, such as IoT, big data, AI etc., and integration of cyberspace and physical space. It follows hunting, agriculture, industry, and information from Society 1.0 to 4.0. Supercomputing is changing now. As I mentioned in the previous slide, we have new types of workloads related to big data analytics, AI, and machine learning, in addition to CSE for simulations. Integration and convergence of S+D+L is important towards Society 5.0. Our approach is based on AI for HPC or sophisticated simulations. We are now introducing 2 platforms for integration of S+D+L, which will start operations in spring 2021. One is BDEC focusing on simulations. Another is Data Platform MDX, which is a cloud-like system mainly for data analytics and learning. BDEC system, Big Data and Extreme Computing, is the target system of the project and platform for S+D+L with more than 32 petaflops, 8.05 petabytes per SEC for memory bandwidth. Operation starts in 2021 spring, and hierarchical hybrid and heterogeneous system. Simulation nodes for HPC with more than 25 petaflops is based on many-core CPU with high bandwidth memory. Data and learning nodes are GPU cluster with more than 7 petaflops is for data analytics, AI, and machine learning workloads. Some of data and learning nodes are connected to external resources directly. This is how we utilize the BDEC system for integration of simulation, data, and learning. Optimization of models and parameters for simulations is done by data analytics and machine learning. This is integration of S+D+L. h3-Open-BDEC is the innovative software platform for integration of S+D+L on the BDEC system. It is a 5-year project supported by Japanese government since 2019. PI is Kengo Nakajima and total budget is $1.41 million for 5 years. Collaborators are specialists of computer science, computational science, numerical algorithms, data science, and machine learning. h3-Open-BDEC is the innovative software platform for integration of S+D+L on BDEC, which consists of numerical algorithms and library. Framework for application development, integration of S+D+L. And control, integration, and utilities. Extracting the maximum performance of the supercomputers with minimum energy consumption. This slide overviews h3-Open-BDEC for control and integration of various workloads, by heterogeneous container technology. It has flexible interfaces with 2 layers. We have 2 significant innovations in h3-Open-BDEC. One is innovative method for numerical analysis with high performance, high reliability, and power saving based on the new principle of computing by adaptive precision, accuracy verification, and automatic tuning. Another is Hierarchical Data Driven Approach, hDDA, based on machine learning for integration of S+D+L, AI for HPC. Data Driven Approach, DDA is a widely known method. Technique of AI and machine learning is introduced for predicting the results of simulations with different parameters. DDA generally requires order of 1,000 to 10,000 runs for generation of training data. We are proposing hDDA, hierarchical DDA in this project. Simplified models with coarser meshes, but preserving original features of physics, for efficient training are constructed automatically by machine learning using various types of methods, such as feature detection, adaptive mesh refinement, model order reduction, uncertainty quantification, and sparse modeling. One of possible applications for integration of S+D+L using h3-Open-BDEC is simulation with data assimilation. We are working together with AORI, University of Tokyo, and Riken RCCS, in atmosphere-ocean coupling for weather and climate simulations. Moreover, we also started collaboration with Earthquake Research Institute, University of Tokyo, for earthquake simulations with real-time data assimilation. We can extend this idea to real-time disaster simulations, such as flood and tsunami. Furthermore, we can apply integration of S+D+L to existing simulation codes, such as OpenFOAM. This slide overviews 3D earthquake simulation with real-time data observation and assimilation. JDXNet is the seismic observation data exchange and distribution network in Japan, and it distributes the seismic observation data of the 9 national universities, JMA, NEED, JAMSTEC, AIST etc. We utilize real-time observation data including satellite data of JDXNet through SciNet. This application is for safer evacuation in cases of emergency. Improvement of underground model by machine learning will be done under normal operations. Example of 3D earthquake simulation with real-time data observation and assimilation. It starts from interpolation of observation, and switch to pure simulations. This is the final slide. By integration of S+D+L, using h3-Open-BDEC, total energy consumption, or total computation time, for simulations will be 10% of that by the conventional methods for simulations with parameter studies. h3-Open-BDEC is the first innovative software platform for integration of S+D+L on Exascale systems, where computational scientists can achieve such integration without supports by other experts in data analytics and AI and machine learning. Source codes and documents in English are open to public for various kinds of computational environments. Thank you very much for your attention.